rubber. Yeah. Okay, let me share my slide first. Before I forget, yeah, please, you have to submit your project, yeah, the only project. So please submit within a week after the final exam. If I'm not mistaken, I have set up in Putra Blast that you have to submit on the 22nd, on the 23rd, yeah, on the 23rd of July. That is the latest date where you have to submit your project, yeah, a week after final exam. Okay, you have to give me 3 to 4 days to do the grading, yeah, because the system will close, yeah, for me to enter your final marks will be 12 days after the date of the final exam, including the date of the final exam. So this indicates that I have to input the mark by latest on the 27th of July. And that's why I need you to submit your project by 23rd of July, okay, in Putra Blast. Please bear in mind that personally, I will do the personal evaluation, individual evaluation on your project. You know why? Because some of you cannot cannot answer the final exam. I will always check the project, because the project will represent the real, the real the real commitments, into this course, because you have been given more than 8 weeks to complete the project. It's a long-term assessment, so please do well in your project, so that it will become the the only way, for you to improve the marks in case that you cannot answer the final exam, or you have any other difficulties, so that I will always refer to your project. Okay, sometimes the student did well in the final exam, but they submit to me only one page of project. That is very, I consider that is very unethical, unethical behavior. So I was so unhappy that was in the previous 2 semesters. So please, because you have been given more than 8 weeks to complete the project, so please do well, in your final exam as well as your project. Okay. Okay, let me share the slide. Okay, now is on lecture 14A. I mark as lecture 14A. This is only a revision, for those who who still notice that this is a part of the lecture which is covered in environmental engineering subject. So I'm going to go through this very fast, because this is not really our interest. Our interest is to go into the design of the septic tank as well as odor removal system. But we cannot simply proceed, into the topics of septic tank without going through the process, and I consider this as a revision, to all of you. Okay, so basically sludge treatment involve these five treatment process. These five treatment process including thickening, stabilization, conditioning, dewatering, and reduction. They are not necessary. All of these process are not necessary. It's not a compulsory treatment, but thickening, dewatering, and stabilization, they are the major processes that involve. So the spirit of having the conducting the sludge treatment is to reduce the volume of the sludge. That is the reason why that we want to conduct a sludge treatment, to reduce the volume of the sludge. So how? how we can reduce the volume of the sludge. Yeah, so the major ingredient of the sludge, yeah, is actually water. Yeah, so the purpose, the aims of conducting all these processes, yeah, especially thickening, dewatering, to remove the moisture content, to remove water from the sludge, yeah, so that we can reduce the volume of the sludge. Why do we need to reduce the volume of the sludge? Yeah? As mentioned by Mr. Khairil during our visit, they have to pay for the sludge treatment. The water treatment operator, they have to pay for the sludge disposal. So that's why they would like to avoid, yeah, producing uh, large volume of sludge. Yeah, so to produce very little amount of sludge, it has to go through few processes. The major one and the first one is thickening process. Okay, let's watch the video. I think this is a very short video, and I not really important because you have done your site visit, so you should be able to explain better regarding on the sludge treatment.
Pada mereka-mereka di luar sana yang belum lagi mendaftar ibadat korban, apa masalah anda Sibuk sangat ke hidup yang tak boleh nak buat ibadat korban? Saya yang tak puasa pun.
Okay, this is a sludge thickener with a flocculation tank. Yeah, so in during sludge treatment, yeah, there will the another polymer, another set of polymer will be added. Yeah, polymer is as a binding agent, yeah, to separate the sludge and water. It will bind the sludge. Okay, this is after dewatering process. Yeah? So sludge which has been dewatered, yeah, is known as sludge cake. Yeah, is known as sludge cake. So the major component of the sludge definitely the solid, yeah, the solid from the waste, as well as the activated carbon, yeah, because activated carbon is a part of the treatment, and also the polymer which has been added earlier. Yeah, so this is the reason why the sludge produced from water and wastewater treatment are considered as hazardous waste. Yeah, they have to be treated as hazardous waste because the ingredient is not only organic. Yeah, the ingredient including the polymer added as well as the activated carbon. Okay. So the slush cake, yeah, normally very low in terms of moisture content, very low in terms of volatile solid, yeah, and very low in terms of the in terms of the total solid. Sorry. No, the same one. You see? Not the same one. Different. Okay. This is the thickened sludge. Sludge after addition of the polymer, and now they are separated from water. Now they are discharging the dewatered sludge. The sludge were no longer or very low water level.
Rub it all over. Yeah, the book is they like make snap, but this is so much better. Absolutely. So the Illinois and Iowa, the recipe. Yeah, label it at everything. We got to help, because, I still think, it's not actually the 70s, where you're going to, well, you think it's more than, it's like probably 15%. So, yeah, the way you were squeezing it, yeah.
So these are the addition. And these are the slush cake. Yeah. I think in water treatment plant that we visited last week, they do have this one. This one. And we have this one after the slush. For water treatment plant, it's not much the production of the slush, but if we are talking about wastewater treatment plant, they are very significant. Sometimes they have no idea, the wastewater treatment operator, what to do with the slush cake. Okay, because the slush cake is the ingredient including not including the polymer, the activated carbon, which is no longer suitable as a fertilizer. Okay, and people are also reluctant to use the sludge as a source of fertilizer because they are human waste. Yeah? So we can use for non-crop plant now, especially for gardening purposes, but not the crops plant. Yeah. Right. Let's go to our lecture today. Yeah, it's on sludge treatment, but very quick one, yeah, because it's only a revision. So sludge treatment process are concerned, yeah, with the separating of the large amount of water. This is why that this step is extremely an important stage. Yeah. It start with the thickening process, yeah, which is separating as much as water, whether by gravity or flotation. There are two methods. If by gravity, it will works exactly like sedimentation tank, yeah. But if through flotation, it will works exactly like dissolved air flotation, where we will inject the air and it will allow the sludge uh, to submerge, sorry, the sludge to float on the surface of the water. So like exactly the one that we seen before in during our visit, yeah, dissolved air flotation, where there is a sludge, yeah, which is stagnant on the surface of the water. That is known as a flotation method. If by gravity, the sludge will settle to the bottom part of the tank. Yeah, this one is very conventional system. Yeah. Next is stabilization process. After thickening process is stabilization process. Okay, this step is not applicable in all water and wastewater treatment plant. Yeah, it depends on the end user, yeah, on what is the purpose of the sludge. Yeah. If the sludge is going to be used as fertilizer, if the sludge is going to be used as soil conditioner, is sludge to be used as a source for composting, then we have to do stabilization. Yeah, otherwise it's considered as a waste. Yeah, because if there is no uh, reuse a product, yeah, from this treatment, which is the sludge itself. Therefore, there is no need to conduct stabilization process, because this process is only required if we are to reuse the treated sludge. Yeah, stabilization process including anaerobic digestion. Okay, next one is conditioning. Yeah, conditioning is the addition of the chemicals, including the polymer. This is another version, yeah, another version of separating water and the sludge. Just now, if you go back to the first step, which is the thickening, this is through mechanical as well as physical process. Yeah, how the sludge can be separated from water. And the third process is conditioning. This is where it will be further get separation, where further separation will occur due to the addition of the polymer. Yeah. Next is dewatering process, separating water by subjected to the sludge, by subjecting the sludge to vacuum, pressure, or drying. And the final one is the reduction. Yeah, it's converting the solid to a stable form by wet oxidation or incineration. We don't have any of this. Yeah, normally after dewatering, yeah, then the sludge is ready. Yeah, it's ready to be sent to the landfill. Okay, these are the steps that we have discussed earlier. Okay, so we send in this country, normally we send the sludge to the specific landfill which handle the hazardous waste. Yeah, so the cost, yeah, will be paid by the water or wastewater treatment operator. Yeah, if the cost is increased, then the consumer have to pay for the service. Yeah, so that's why they have been thinking of reducing any of the technology that can reduce the sludge, yeah, the sludge production. Okay, what is actually the constituent of the sludge? Huh? First is the grit. Yeah, the grit, which is the sand or the broken glass, the nut, the balls, yeah, and other dense material. This is from the grit chamber. Yeah. Second one is the primary or the raw sludge from the primary tank. Yeah. Grit is from preliminary tank. Kan? Okay. And next is from secondary sludge. Yeah. So this is the major contributors to the sludge which has to be treated, because if in wastewater treatment plant we have waste activated sludge, yeah, from conventional activated sludge process. Yeah. So these are the major contributors to the sludge production. On top of that, if tertiary treatment is to be applied, especially we would like to introduce for nitrogen removal, so that this is again where the sludge can be produced from anaerobic digestion process, or different types of the digesters will produce maybe higher or lesser volume of the sludge. For example, if we employ the stirred tank reactor, it will produce large volume of the sludge. But if we employ upflow anaerobic sludge blanket reactor, the sludge will retain within the reactor, so that will reduce the sludge production from the system, if tertiary treatment is to be conducted. Okay, let's see. The thickening process it is usually accomplished in two ways. Whether it's through flotation or to gravity. So as I mentioned just now, the goal of having this treatment is to remove as much as water before it will go through the next process. Basically, this is a low cost means of reducing the sludge volume. Yeah, and it works very well to reduce the volume of the sludge. This is air flotation thickener. So you can see here that the airflow will be injected into the system, and you can see that the thickening sludge collected, which is exists on the surface of the system. Thickening sludge blanket. Normally we will remove this using the scrapers. This is exactly what we have seen before during the visit. So if we employ the flotation methods, so the air is injected, and these are the recommended pressure for the injected air. But this method involve high energy consumption, because we have to apply the pressure as well as use the pump to inject the air, as compared to the gravitational method. So the more that the bubbles that we can produce, the more that the injected air into the system, so that we can remove as much as possible the sludge. Next is on gravity thickening. This is a simple and inexpensive process. They use the concept of sedimentation process. You allow certain hydraulics retention time as well as detention time, so that you will allow the sludge will settle to the bottom part of the tank. Very simple, but you need to set the time. You need to give them some time. Otherwise, the sludge will not settle properly to the bottom part of the tank. Okay. Next is on stabilization process. The principal purposes of sludge stabilization is to break down the organic solid biochemically. So that's why I mentioned just now. Stabilization is not very common in all water and wastewater treatment plant. Even though in this country we do have few wastewater treatment plant that do have a stabilization process. The one in Bunus, the Wangsa, as well as the one in Lembah Pantai. The rest of the treatment plant, since they are going to sent to the landfill, therefore no stabilization process were conducted. So stabilization process can be conducted using two methods. The first one is aerobic digestion, by injecting the air into the sludge, and the second one is anaerobic digestion, where they have a chamber without any oxygen inside. So this is the very common method for the sludge treatment, where they produce methane from the anaerobic digestion. Unfortunately, the sludge produced from water and wastewater treatment plant, the production of methane is extremely low, without any addition of other substrate. If we would like to promote more methane production to be produced, then we have to add other substrates, including the food waste, because recently they have added food waste into the digester that contain the sludge from wastewater treatment plant, so that to enhance the potentials of the sludge cake produced, so that we can they can use the energy, because methane can be converted into electricity. So basically, these are the standard rate for anaerobic digester. Anaerobic digester is a full closed system without any oxygen. It requires airspace. Yeah, supernatant, and at the bottom part normally will be the sludge. So employing this system, you will use a low amount of energy consumption. However, you need to avoid any extreme loading rate. Yeah, you have to control the volume of the sludge to be treated. Yeah, otherwise, if you put too much volume of sludge to be treated, it will the pH will be significantly reduced. The pH will be significantly reduced, and it will stop producing the methane. That is the indicator that the microbes within the tank is about to die. Yeah, so once you reach the pH of 4, that is the sign of the severe inhibition. Okay. Slash conditioning. Yeah. Next, after stabilization is conditioning. This is where the polymer, or the coagulants are being added, yeah, including the PAC. Yeah, so the role of polyaluminum chloride, as a binding agent, yeah, so that it can clump all the sludge, and again to get separating with water. Yeah, so chemical coagulant act to clump the solid, yeah, so they can be easily separated from water. Okay. On top of that, yeah, the sludge conditioning can also be conducted using heat treatment, where these are the recommended temperature to the maximum of 230 degrees Celsius and a pressure of 2000. Definitely, we have to apply pressure, otherwise we cannot reach at 230 degrees Celsius. So under this condition, water that is bound up in the solid is released. Yeah, so this is another of methods or action to be done to further improve the removal of moisture content. Okay, the advantages is it can produce sludge that dewaters better than chemically conditioning sludge. So this is the option. Yeah? So the one that we normally practice in this country is the sludge conditioning using chemical conditioning. Okay. On top of that, heat treatment can also be used, yeah, as a conditioning process. Yeah. Uh, the advantage is it can produce a sludge that dewaters better than chemically conditioning sludge, because we apply heat. The disadvantage is complex operation and maintenance. Okay, next, sludge dewatering. Okay, there are three methods involved. The first one is sludge drying bed. Yeah, this is the one that we have seen before, and because this is normally used by the small plant, because of their simplicity of the operation and maintenance. Yeah, it can be built without any provision, yeah, for mechanical sludge removal and roof. So this always being the selected as dewatering methods. On top of that, we can also use vacuum filtration, yeah, as well as the bed filter presser. Yeah. I think I do have one video that I can share with you regarding on bed presser. Okay, bed filter presser.
I think we
Okay, watch one video on the bed filter presser. So this is how a black filter look like. I think this is another one. Now these are the animation.
Pada mereka-mereka di luar sana yang belum lagi mendaftar ibadah korban, apa masalah anda Sibuk sangat ke hidup?
Wet sludge enters onto the press through a sludge inlet box, where it is gently dispersed and spread evenly. Sludge is spread evenly along the gravity deck by a sludge leveling bar and passes through a series of clouds, aligning the sludge into rows, allowing the free water to cascade off the sludge through the belt. Sludge then travels onto the wedge zone, where the sludge is spread evenly and gentle pressure is applied, further dewatering the sludge. The pressure zone is a series of different diameter rolls arranged vertically where extreme pressure is applied, allowing for maximum dewatering. The belts are finally separated at the cake discharge zone, and scraper blades are used to remove the dried cake from the belts.
Okay, that is the back filter pressure. The advantages is it does not have the sludge pickup problem and lower energy consumption. Yeah. Next is the reduction process. Yeah. If a sludge used as a soil conditioner, so it's not practical. Yeah. If we are to use the reduction, so if we have nothing to do with the sludge, yeah, we have no idea what is the product that can be developed after the sludge treatment, then we can use incineration. Yeah, but it's not common. Normally we send the treated sludge to the landfill. Okay, so to minimize the amount of the fuel used, the sludge must be dewatered before we can use in the incineration. If incineration is a combustion method, in this country currently we use incineration if we are to deal with the toxic waste or the clinical waste. Yeah, mostly the clinical waste. So the issue with the incineration is the system can completely, yeah, turn any kind of waste into ash, because we are going to burn them at 1000 degrees Celsius. But there is another issue in order to prepare the sample in order to prepare the waste before it can be burned in incinerator. The major problem is to reduce the moisture content. Yeah, otherwise it will not work well. Yeah, it will not turn the waste into the ash. Yeah. On top of that, most of the sludge contain high concentration of sulfate, high concentration of phosphate, yeah, all those negative ion. This negative ion actually can turn into acidic glue. Yeah? So when they turn into acidic glue during combustion, it can cause corrosion to the incinerator itself. Yeah? So these are another issue if we employ incinerator. Okay, sludge disposal, as what we have seen before, within twice a week, or once a week, the lorry, the truck will come and pick up and send to the landfill. These are the common methods. Okay, all right. Next, example one. We have three examples today. Yeah, example one, lecture 14. A sedimentation tank is treating about 4.5 million liters of sewage per day, containing about 2,075 ppm of the suspended solid. The tank remove 50% of the suspended solid. Calculate the quantity of the sludge produced per day in bulk and weight. Okay, you are given the information that the moisture content of the sludge is 98%. Yeah, the sludge itself, can you just imagine, 98% is water. Only if we are talking about 100 kg of the sludge, 98 kg is water and only 2 kg is the solid. Yeah, that's why the treatment is extremely important, because having this treatment can significantly reduce the volume of the produced sludge. Yeah? Alright, the solution: volume of the sewage treated 4.5 times 10 times 10 to the power of 6, or this is MGD, mega gallon liter per day. This is the sewage to be treated. Okay, the percentage, the concentration of the suspended solid is 275. Yeah, so it's also equal to, if 275 ppm equal to 275 milligram per liter, which is also equivalent to 275 times 10 to the power of 6 kilogram per liter. Okay, in 1 liter of sewage 275, times 10 to the power of minus 6 kg of suspended solid is present. Therefore, in 4.5, because we are treating about 4.5 megaliter of the sewage. So now we would like to know what is the suspended solid that is available in the sewage to be treated. So in this case, 275 times 10 to the power of minus 6 times 4.5 times 10 to the power of 6, which is the wastewater or the sewage. And you will get 1275 kg per day. This is the mass of the suspended solid available in the sewage to be treated, because the original volume of the sewage or the flow rate of the sewage is 4.5 megaliters per day. Yeah? And you're also given the percentage of solid removed in sedimentation tank. Okay, we know that the sludge treatment is the final barrier. Yeah, for this reason, we have to always consider certain rate of removal. Yeah, so in this case, you were informed that the percentage of the solid removal in the sedimentation tank is about 50%. Yeah, so we know that for this reason, we know that the sludge which is required to be treated is only half, of the suspended solid which has been calculated earlier. In this case, about 618 kg per day. Okay. You know that the moisture content given to you is about 98%, the moisture content of the sludge. Okay, now we have to make some assumption. Let's use the numbers of 100 kg because it's easier. If let's say that you have 100 kg of wet sludge, you have 100 kg of untreated sludge. Wet sludge is untreated sludge, and you know that the percentage of the moisture content is 98%. For this reason, we can conclude that 2 kg of the sludge is the solid, 98 kg of the sludge is the water. Why? Because the moisture content is about 98%. This mass of the wet sludge made, about 618 of the solid, times 100 divided by 2. And this one is to calculate the mass of wet sludge. So assume specific gravity of the wet sludge equal to 1.02, and the unit weight of water is always 1000 kg per meter cube. So you need to calculate the unit weight of the wet sludge. Okay, unit weight of the wet sludge is equal to the specific gravity of the wet sludge times the unit weight of water. In this case, 1.02 times 1000. Yeah, what is 1.02? 1.02 is the specific weight of the wet sludge, yeah, or the untreated sludge. Yeah. So the unit weight is 1020. Then the volume of the wet sludge produced per day, yeah, you have to divide the weight with the 30940 divided by the this now the mass, yeah, the mass, which is now the weight of the wet sludge, is about 30,900 divided by the unit weight, which is 1020 kg per meter cube, and then you will get the volume of the wet sludge produced per day, about 30 meter cube. Yeah. Sludge digestion process, normally the process, the indicator that we have to monitor, yeah, during the sludge digestion, yeah, which is including the pH, the biogas production, the volatile solid removal, the COD removal, as well as the alkalinity. These are the major indicators, yeah, or the parameters that can tell us the process performance. Yeah. So on top of that, there will be 65% to 70%, yeah, of methane to be produced. Yeah. This is in terms of the composition. You can get the lowest of 50, but normally 62 is always the best numbers. Yeah. This is the many studies have reported, yeah, the percentage of methane produced from their system is about 62%. Alright, so there are two methods, if you are to employ anaerobic digestion, two conditions. The first condition is known as thermophilic temperature, which is about 40 to 60. And thermophilic temperature, we can apply these methods because it can produce higher biogas production. Unfortunately, if your sample is very fragile in terms of acidification, yeah, for example, like food waste, so thermophilic might not be a good choice, because the system can inhibit very quickly. The system can fail very quickly. So always use the mesophilic temperature, which is around 25 to 40. Normally we set around 35 to 38 degrees Celsius. Because why? First is because we would like to reduce the energy usage. So that the temperature of the mesophilic is lower. Second is we would like to produce a stable system. Yeah, we are not running to produce very high biogas production, but but we end up having a failed reactor. Okay. So we monitor the pH, normally 6.5, 6.2. If below than 6, then you have to call the supervisor. Yeah? That indicates the system is about to fail. Yeah? So acidity can increase first if we use very acidified sample like food waste. Yeah? We have overloaded the system. You put too much waste. Sudden admission of the new types of waste. This is due to the shock, yeah, and over withdrawal of the digested sludge. Why this one is related? Because in digested sludge, there are certain population of microorganisms. If you take out if you take out so much sludge, yeah, you will end up having a system with low population of microbes. Yeah. All right. Example 2, lecture 14A. Design a gravity thickener for a combined primary waste activated sludge. We are to design a thickener. Yeah, in this case, we do have different types of sludge. Average design condition for first for primary sludge, this second waste activated sludge. So primary sludge is from the primary treatment, while waste activated is the one processed from secondary treatment. The specific gravity is given as follows: the percentage of solid and also given, as well as the flow rate. Yeah. Compute the dry solid at peak design condition. Yeah, please bear in mind, in this case, we have to peak design, as well as the average design. Okay, so is not responding. It's not responding. Audio. Maybe I have to close. Let me deactivated the hand tools. Okay, sorry for the interruption. Yeah, I have to turn off my mobile, my laptop for a while. Okay, let me share again the screen. Okay, so in this case, we are to design a gravity thickener. First, we have two circumstances. The first one is the average design condition. The second one is the peak flow condition. So compute the dry solid at peak design condition. For the primary sludge, we know that the flow rate is 420, is 420 is given. in the final column, in the final column, uh, here, then times with the specific weight, times with the percentage of solid, then you will get in kg per day. You will do the same for the waste activated sludge. We'll do the same, and you will get the dry solid at peak design condition for both sludge from waste activated from the secondary treatment as well as the primary treatment. So combine the sludge mass is equal to 14,700 plus 5,700. So you will get the sludge mass in kg, and combine the sludge flow rate. The flow rate is given in the table, which is 2,500 plus 420. Next, compute solid concentration of the combined sludge, assuming the specific gravity of the combined sludge is 1.20. Okay, where can you get the specific gravity? In this case, in this case, you are given the specific gravity for the sludge. For the primary sludge is 1.03. The waste activated sludge is 1.005. My recommendation is, if you are to calculate for the combined sludge, then you get the average of these two values. 1.03 plus 1.005. So in this case, the combined sludge specific gravity is equal to 1.02. So you can calculate the percentage of solid. In this case is around 0.69. This one calculated earlier, this one already calculated, this one is the specific gravity of the combined sludge. Next, compute the surface area on the solid loading rate, because the solid concentration is between 0.5 and 1.5%. Select a solid loading rate of 50. Okay, how to select this and where to find this value? You have to refer to table 1490. 1490 is this one. Okay, in this case, we are designing for waste activated sludge and primary. So we are referring to the third row. First, we are designing for a combined system. A sludge from two sources. Okay, let's start from the top of the table 1419. This is, we are to design a thickener from a separate source as individual thickening process. One, in our example today, we are referring to a combined system where we are to design a thickener for the treatment of sludge produced from primary as well as the secondary treatment. So in this case, you are referring to the third row. This is how we get the volume, the value of the solid loading. So in this case, the solid concentration is between 0.5 to 1.5. Let's see the solid concentration. If you are referring to the third row, the solid concentration is about 0.5 to 1.5, correct? And also the loading rate of 50. Loading rate 50. So the given value is between 25 to 70. So you decide which value to be used. As long as within this range, so you are going to get the correct answer. And then you can calculate for the area. After calculating the area, you can compute the hydraulics loading rate, because you know the flow rate. The flow rate already calculated earlier. Based on the flow rate given in the table. And then you can calculate the diameter. Assume you have to use two thickness, then you have to divide by 2 lah. Okay, if the question instruct you to design for 2 thickness, then divide by 2. If not, then only consider as 1 thickness to be used. Okay, the final part for this section is on septic tank. Okay, there are 2 types of septic tank. First is the septic tank for the individual house. Second is known as communal septic tank. Especially in remote area, in this country, in remote area, they used to have individual septic tank. However, in urban area, sometimes we do have the residential area where they use the communal septic tank. But this is for small numbers of residential area. According to Malaysia standard, yeah, normally they will allow the city council and the sewerage department will only allow to the maximum of 20 houses. Yeah? If they submit the permission, they submit the application to get the permission to develop the communal septic tank, yeah, the developer, then the contractor, then they will, the city council as well as the sewerage department will grant the permission. Yeah, if the house is 20 or less, yeah, then they can use a communal septic tank. For this reason, the waste, the black water will not be discharged into, will not be treated in no, in sewerage treatment plant. It will be just treated because nearby the area, because communal septic tank, it will be located within the residential area. Yeah, but for uh, an area with a maximum of 20 houses, yeah, but in other countries sometimes they allow for the maximum of 30 houses. Yeah. All right, so these are the cross section of the septic tank. We have the scum layer, we have the sludge layer, the clarified zone, and the outlet and the inlet pipe. This is another version of the septic tank. Yeah, we have the cap. Yeah, we have the inlet T, the outlet T. This is the effluent. You see, after certain period, water, the supernatant will be developed. Yeah, so this is the layer of the sludge. So in this country, if we are to use the septic tank, the desludging has to be conducted at least once in 2 years. Yeah, so it has to be, they have to do desludging. Yeah. Okay, a septic tank is an underground chamber, yeah, made of concrete, fiberglass, the plastic, yeah, which a domestic wastewater flow, yeah, for basic treatment. So this is mainly on domestic wastewater. So septic tank system are a type of simple on-site sewage facilities, yeah, and they can be used in area which is not connected to a sewerage system, especially the rural area. Okay. All right. The final example for lecture 14A is on septic tank. Yeah. Design the dimension of a septic tank for a small colony of 150 person. Okay, this is 150 population. Let's imagine that we have 5% for each houses. That indicates that we are going to design for 30 houses, and we are going to design the septic tank for 30 houses, where the water supply from the municipal head works at the rate of 120 liter per capita per day. Okay, so this is the volume of the wastewater produced. Yeah? Normally in this country, we shall take as 2 to 5. Yeah? We shall take as 2 to 5. 1 second. Okay. Yeah? Um, So in this case, the volume of the wastewater per person per day is 120. Okay, so percentage of water supply that becomes sewage is about 80%. Let's say, in the question is mentioned that 120 liter per capita per day, per person per day, but only 80% is turning into sludge or become the sewage. Sorry, sewage, yeah, not sludge. because in this question there are two different terms. Yeah, first is the sewage, second is the sludge. Okay, what is the difference between these two terms? Yeah, sewage is the wastewater. Yeah, now in the question is mentioned that the wastewater produced per person per day is 120. Yeah, and only 80%, yeah, out of the wastewater produced turns into sewage. Okay, so and another one we have rate of deposited sludge. Deposited sludge meaning to say that is the product of the waste, yeah, which has been treated. Yeah, in this case is about 30 liter per capita per day. So sludge is referred as the inert matters that is produced, yeah, during biological process. Yeah, it's not a fresh wastewater. Okay, the detention time is 24 hours. The period of cleaning is 1 year. Period of cleaning meaning to say that the duration of the desludging. Yeah, because normally for septic tank, desludging is compulsory. Yeah, the depth is between 1.2 to 1.8, and the recommended size is 2B to 3B. Yeah, length is equal to 2B or 3B. Next. The quantity of water supplied equal to per capita rate times the population, as mentioned just now, 120 per capita per day times 150. 150 actually the population is not liter per day. Liter per day is supposed to be here. Yeah. So but the final value here is correct. The quantity of sewage produced, because only 80% turn into sewage, so 80% time 18,000. The quantity of sewage produced during detention period, because now the detention period is only 24 hours, so that you can get the volume. Yeah, because 14,400 liter per day. Yeah, so you would like to know how much in terms of volume being produced. Then you can times with the detention time. So per day, basically, it's about 14,400 liter, yeah, of the sewage to be treated within the period of 24 hours. Okay. So, solution, the volume of the sludge deposited, rate of the sludge deposition is given 30 liter per capita per day. So, as I mentioned just now, the sludge is the product, yeah, the inert matters or inert material that is produced, yeah, during biological process. Yeah. So, times numbers of person and times the period of cleaning, so you will get the volume of sludge deposited. The total required capacity of the tank, yeah, so volume of the sewage, which is 14,400, yeah, plus the deposited sludge. Yeah, we have to consider the deposited sludge. So overall, the required capacity of the tank about 18,900 liters, which is equivalent to 18.9 cubic meters. Okay. Take the depth of the tank. Just now earlier you are given the range, yeah, so you can choose 1.5 meters. The surface area of tank is equal to 18.9 cubic meters divided by 1.5, so this one is the area. So take the length to width ratio is equal 3 to 1, yeah. So the length to the times the width is equal to 12.6, yeah, because this is the area. So that you solve. I think this one you should be having no problem to solve, because L equal to 3B. Yeah, so 3B times B, yeah, 3B times B, yeah, equal to 12.6. Yeah, so that you can get the value of B equal to 2.0 and L equal to 6 meters. Yeah, please let me know if you have no idea how we can reach to this value, because this is the common design calculation. Yeah, but I think please let me know in case that you have question how that we can reach the value of 2.05. Yeah. Earlier you are given in the question that this is the recommended ratio to be used. So please bear in mind, whenever we come up with a design, we have to consider the freeboard. So in this case, the freeboard is taken as 0.3 meters. So the total depth is equal to 1.8 meters. So the dimension, The real dimension of the septic tank is 6 times 2.1 meters times 1.8. Okay, so this is a complete design for a septic tank. Yeah. Do you have any question regarding on this example? Have any question?
No, doctor.
No, doctor.
Alright. Okay, thank you. Okay, let's continue. We have 3 lectures today. Let's continue to the second part of the lecture on the order treatment. So as some people mention as order treatment, some people pronounce as order treatment. Yeah. Okay, these are the gases that produce in water or wastewater treatment plant which require treatment. Okay, so we are going to design for a scrubber unit today, and these are very popular. These equipment are very popular not only in water or wastewater treatment for the odor control treatment, but also popular for the air pollution treatment device. Yeah, scrubber. Okay. Let's watch one short video. See.
Kepada mereka-mereka di luar sana yang belum lagi mendaftar ibadah korban, apa masalah anda Sibuk sangat ke hidup yang tak boleh nak buat ibadah korban?
Whether it be finding other water sources to ensure Avondale wastewater treatment plant. BPV knew it would benefit the area here at the South Wastewater Treatment Plant as well. The new odor control system at the South Wastewater Treatment Plant is a major improvement for people who live in the area. Let's take a closer look at what was done and how it works. The gas primarily responsible for the foul odor in untreated wastewater is hydrogen sulfide. The turbulence created by the inflow of wastewater helps disperse that hydrogen sulfide and in turn the odor out into the open air. To mitigate this problem, the first major step was to place covers over wastewater tanks and channels where the wastewater is churning the most. The covers capture the gas before it is released into the open. Seeing how the South plant looked before these covers were installed, you can get an idea of how much less hydrogen sulfide is being released into the air. Approximately 200 covers were installed. That's a total of 7,000 square feet. While those covers prevent the gas from being released, that hydrogen sulfide still needs somewhere to go. That's when we allow Mother Nature to step in and do her job. About 400 linear feet of ductwork installed within the covered tanks and channels blows the gas through a biological tower. Inside the structure are microorganisms that love to feed on hydrogen sulfide. By the time those microorganisms do their job, 99% of the hydrogen sulfide has been removed, along with the odors associated with a wastewater treatment plant. This improvement project was a major investment into the community by BPV, with project costs reaching $2.1 million. The project was done with a great deal of help and support from the city of Brownsville, notably from the commissioner of this area, Ricardo Longoria Jr., who wanted to make sure that the needs of his constituents were being met.
I've been living here in the neighborhood since 1973, and the plant's been around since about 1955. Every time that you came to our neighborhood, when you would drive down, you would always get the smell of raw sewage when it was coming in. So I've been in office now since 2003. That makes about 13 years. And I got together with our CEO from BV, Mr. John Bruziak, and a couple of members of the board since back then. And we've tried several things to be able to get, to control the scent, to control the odor. And it wasn't until about 2 years ago that we tasked Ambiotech Engineering to come up with a plan. And it's basically what you see behind you right now. And this is an odor control system that's been set in. And it's also at our Robindale plant here in Brownsville. This facility can work up to 12.7 million gallons a day. Right now, it works at about 5.6, so we're not even halfway. So this is something that's been a long time coming. We were finally able to get together and finally come up with a scientific solution that would take care of the problem. And that's something that has been a long time coming to this neighborhood, and both the city of Brownsville and Brownsville PUB are very proud of that we finally been able to accomplish for the people and for the citizens of Brownsville.
And now that the work is complete, Commissioner Longoria says that the difference is clear.
Everybody stands to benefit. Everybody stands to win. The city of Brownsville owns 81 acres across the street. As you look at the future of Brownsville, we're always ahead. We're always planning 10, 15, 20 years ahead. As you look into the future, you see a possibility of probably maybe the university expanding here into the neighborhood. And of course, by us having taken care of this problem right now, you start preparing for the future. You start making it a more viable community. You start making more viable projects would be able to come into the area. So preparation is key. Having done this right now prepares for future commissions, future boards, to be able to give them that accessibility to our area, making it more viable.
As a municipally owned utility, EPB always puts the needs of its customers first. And this project shows the importance of having a utility motivated toward meeting customer requests, as well as one that's here to work alongside the city to accomplish that goal.
Okay. A very well planned project for odor control. Otherwise, the community will not be happy. Especially when we are dealing with hydrogen sulfide. This is a very annoying gas because it smells like a rotten egg. It smells like a rotten egg. It's not like methane. Methane is the odorless gas. But hydrogen sulfide, ammonia is the gas that it can have a very bad smell. It's unpleasant odor that can cause rapid corrosion. Not only the issue with the hydrogen sulfide is not only regarding on the satisfaction from the community regarding on the health issue, but it can also cause the problem of corrosion to the equipment that is available within the treatment plant. That's why hydrogen sulfide require a specific treatment so that we can reduce the effect. We can minimize the risk. So the oxidant that normally we use, the chemicals that normally we use for the treatment of hydrogen sulfide, including sodium hydroxide as well as sodium hypochlorite. Okay, let's see. How does a scrubber look like? This is the scrubber tower. And these are the cross section. There are two types of the scrubber that we are going to explore today. The first one is the chemical scrubber. The second one is a biological scrubber. Okay, let's see the difference. So the one that I'm sharing with you is known as a chemical chemical scrubber. Chemical scrubber. In chemical scrubber, you can see that first they are packed bed. This is the packed bed exactly like we have in our filter system, in our trickling media, trickling filters media. So in the packed bed, this is where they spray the chemicals. They spray the chemicals onto the packed bed where the odorous gas will pass through at the bottom part of the system. One, the odorous gas, including the hydrogen sulfide, pass through into from the bottom of the system. It's just an upflow system, because it pumps from the bottom, so that it will pass through the packed bed, which is the chemicals is already available, within the packed bed. So that the chemicals just now is the sodium hypochlorite. This is the oxidant that they use to treat the hydrogen sulfide, so that it will be doing the treatment process within the fixed bed or the packed bed, and it will release the clean air from the system. Okay, so these are the first cross section of the chemicals scrubber. Okay. So chemical scrubber purpose to allow contact between air, water and chemicals. So sodium hypochlorite. On top of that, it can be used to remove also ammonia as well as sulfur dioxide. So these are the three major odor gas that produce from wastewater treatment system, especially during sludge treatment. Next one is biological scrubber or bio-trickling filters. This is the one that we have in Bandar Torazak wastewater treatment plant. The worst case, yeah, because I would say that if we are to choose, yeah, between the chemical scrubber and biological scrubber, I will go for chemical scrubber, because in biological scrubber is the same configuration. Yeah, we still have the filter media, but we have to always spray the nutrient, yeah, because we culture the microbes within the media, yeah, so that the microbes will be doing the treatment to treat the hydrogen sulfide. Yeah, it's not easy because we have to always monitor the pH condition, because we are dealing with the living organism. Yeah, that's why I said I would go for chemical scrubber. Yeah, if we have to choose. Yeah. Okay, so there are two mechanisms that involve. Well, later I will share with you the schematic diagram for the biological scrubber. There are two major mechanisms that involve during the process, the treatment process. First is known as impaction. Yeah. Second is known as diffusion. Okay, figure 1 is the impaction. It involves the water droplet and also the gas streamline. The second is in a wet scrubbing system, dust particles will tend to follow the streamline of the exhaust stream. Yeah, so this is known as impaction. But when it doesn't follow the streamline, yeah, it will known as diffusion. The movement, yeah, is known as a diffusion. It's an irregular motion. Yeah. Okay, these are the chemical scrubber. How does the scrubbers work? The scrubber is a tower equipped with a fan that extracts gases, from the power plant. Yeah. So this is where the contaminated gas in, and this is the pack bed where the scrubbing liquid in. Scrubbing liquid in this case, is the sodium hypochlorite. So gas in, it will get intact with the pack scrubber as well as the chemicals added, the chemical injected in, and they will be doing the treatment and it can collect the clean gas out. Yeah. So at the same time, yeah, because we injected the scrubbing liquid, yeah, they will produce water. Yeah, so this is scrubbing liquid out. Yeah, so the scrubbing liquid comprised of the contaminants which has been removed just now. Okay, these are the how does the pack bed material look like. This is exactly the pack bed material for that we use for moving bed bioreactor. Okay, so these forms of the pack bed material is preferable because they have a small hole within the pack bed, so that allow the longer retention time for the scrubbing liquid, yeah, to stay within the pack bed material. Okay, these are another configuration. We have the configuration. This is gas in. This is the liquid spray, the sodium hypochlorite. Yeah, this is the clean gas out. Another configuration is clean the gas to be treated, and how they splash how they spray the sodium hypochlorite. And the bottom one is the known as a cross flow scrubber. In the cross flow scrubber, we have dirty gas inlet, yeah, liquid distribution, we have drain, and the clean gas outlet. Within the cross flow scrubber, the chemicals will be injected. Okay, next is biological scrubber. Okay, biological scrubber, it works exactly like trickling filters, or sometimes also known as bio trickling filters. They can remove the hydrogen sulfide to the maximum of 100,000 milligram per liter, and the efficiency is about 99,000. This one, the flow rate is about 16 meter cube per hour. Okay, so in this case, in these biotrickling filters, they will culture the microbes, and they will be inlet, for the operator to inject the nutrient. You have to inject the food, for the microbes. At the same time, the clean gas in, the clean gas in, and it will be doing the treatment. So the concept here is the major difference between the chemical scrubber and biological scrubber is the one that we splash on the top part of the system. For a biological scrubber, we splash the nutrient, onto the biotrickling media, because we have microbes, that is living within the media and nutrient as a source of food. One, for the chemical scrubber, we have to splash the sodium hypochlorite. But this system offer greater performance, than biofilter at higher contaminants loading. Okay, right, that's all. Let's go to the calculation. Okay, design for odor control in a wastewater treatment plant. Before we can start with the design, we have to step back a little bit, to check again your understanding on chemistry, form 4, form 4 chemistry. But okay, first, the selection and design of odor control facilities. So how do we select and determine the characteristic and the volume of the gas to be treated? And these are the steps to be taken. We have to characterize the gas to be treated. Because the different gas to be treated, you will have to provide different size of scrubber. Okay, define the exhaust requirement, evaluate the climatic condition and atmospheric condition. When you are dealing with gas, you have to deal with the pressure, you have to deal with the temperature. So you have to know what is the standard temperature pressure. Select one or more odor control treatment to be evaluated. Normally they will start with the pilot scale, and they will perform the life cycle analysis, especially if you are to design for a large scale system. All right, so let's see the gas law. Now we have to do a very short revision here on the gas law. PV, equal to nRT. What is PV? P is the absolute pressure, V is the volume occupied by the gas, N is the mole of the gas, R is the universal gas law constant, which is equal to 0.082, and T is always to be expressed. If we use this equation, T has to be expressed in the unit of Kelvin. Let's say that our temperature is normally expressed in the unit of Celsius. So very easy to convert to Kelvin, just plus 273.15. All right. So whenever we studied about the universal gas law, it can be shown that the volume of the gas occupied by 1 mole of gas at standard temperature at STP is equal to is actually assumed to be at 0 degrees Celsius and at pressure at 1 atmosphere. And this, the volume of gas that occupied at this temperature and pressure is equal to 22.414 liters. Okay, how can we reach to this value? There is a calculation where N is equal to 1 mole, R is as a universal gas law constant, T is 273 plus 15 plus 0. Why 0? Because in this case, we take at standard temperature pressure, where it is 0 degrees Celsius divided by 1 atmosphere, because this is at standard condition, so you will get 22.414. Okay, all right. Conversion of the gas concentration unit. Later in this example, we will be using this equation. This is to convert, if you have concentration in to convert the gas between gas concentration expressed in ppm and microgram per meter cube. Okay, conversion of the gas concentration unit. The gas from wastewater was found to contain about 9 ppm by volume of hydrogen sulfide. Determine the concentration in microgram per meter cube and in milligram per liter at standard condition. At standard condition means to say that at 0 degrees Celsius at 101.325 kPa. This is at STP. Okay. The solution, yeah, compute the concentration of microgram per liter, yeah, using equation 245. So first, the molecular weight of hydrogen sulfide is 34.08. These are the atomic value, yeah, atomic value for the hydrogen sulfide, yeah, for the hydrogen, yeah, times 2, and this is for sulfide. So these are the molecular weight. So we know that the molecular weight for the sulfide is 34.08. Okay, all right. This is the fixed value, and we are dealing with only 3 types of gases. Yeah, we are dealing with hydrogen sulfide, ammonia, as well as I can't remember. Another one is and sulfur dioxide. Yeah, we are dealing with only 3 types of gases. So in case that this question come up in your final exam, I'm not sure yet because the question is not ready yet. So maybe I will provide the periodic table. Yeah, you need a periodic table to calculate for the molecular weight in case it will come out in final exam. But not sure yet because the question is not ready. It's not yet prepared. Yeah. Okay, so 9 ppm, yeah, you are given in the question, it's stated that the it's stated that the it's stated that the concentration of the hydrogen sulfide is equal to 9 ppm. Yeah, so now you are converting. Yeah, you are converting into microgram per meter cube. So 9 ppm is equal to 9 meter cube over 10 to the power of 6 meter cube. Yeah, times the molecular weight divided by the volume of gas at standard temperature just now, 22.4 liters. Just to recap, here, yeah, 22.4, yeah, times this is only the unit conversion. So you will get 13.693 microgram per meter cube. Yeah. So in milligram per liter from ppm, yeah, from if you are dealing with liquid easy, you know why? Especially seawater, especially surface water, groundwater, wastewater, because 9 ppm is always equal to 9 milligram per liter. This is due to the density of water, yeah, because it's equal to 1000. But if we are talking about gas, yeah, it's no longer the same. Yeah, so this is the step where we can convert from ppm to milligram per liter. Okay, so 13,900 microgram per meter cubes. This is the conversion. Then you will get in milligram per liter. You see the difference. Yeah, the difference. 9 ppm is equal to 0.0137 milligram per liter. Yeah, it's no longer the same. Okay. So next example, if the temperature is not equal to 0. In the previous example, we got the volume of gases at temperature 0, at temperature of 0. Yeah, but let's see if the temperature is not at 0 degrees Celsius, let's say in this question equal to 20 degrees Celsius. Yeah, we still have to use the same equation, but in this case, to convert to Kelvin, 273.15 plus 20. Yeah, in the previous example plus 0. Yeah. Okay, so you will get the new volume for the gas to be occupied at 1 atmosphere equal to 34.05, because just now 22 at 0 degrees Celsius, but when it turned to 20 degrees Celsius, the volume increased to 24 liters. Yeah. Estimate the sodium hypochlorite requirement. Yeah. So in this case, sodium hypochlorite that required is 20 ppm. So you have to follow exactly the same step. Yeah? But here, since at different temperature, do not use 22. Yeah? You have to use 24. So you will get the sodium, convert the sodium, so convert the hydrogen sulfide concentration from ppm to gram per meter cube. So this is in gram per meter cube. And if you are to convert from ppm to milligram per liter, you can simply follow the following step lah. Okay, but the only difference here is the volume of the gas occupied, because this is at 20 degrees Celsius. Okay, let's go for our design question, which is the final example for today. Determine the size of composed biofilter needed to scrub the air from 100 meter cube enclosed volume using the design criteria in table 15.14. The table is here. Yeah. Also estimate the mass of the buffer compound needed to neutralize the acid formed as a result of treatment within the filter. Assume 12 air changes per hour are needed, yeah, and assume a bed porosity of 40%. Will the volume selected adequate if the air contains 40 ppm? Yeah, so this is what we need to check. Yeah, of hydrogen sulfide in addition to other odorous constituent. Yeah. Assume an elimination rate, yeah, for the sulfur, because now why we have to consider for elimination rate for the sulfur only, because in hydrogen sulfide, yeah, the toxicity gas and the odorous gas that we would like to pay attention is the sulfur. S here, S in the hydrogen sulfide here. So that's why we need to know the elimination rate of the sulfur. That is why the elimination rate of the sulfur is given in the question, because it is the compound of interest, yeah, compound that we would like to remove. Okay, all right. Estimate the airflow to be scrubbed. Yeah, volume divided by time. So the volume of is given divided by numbers or the numbers of the air changes. In this case, assume 12 air changes per hour needed. So 100 divided by 12, so we get what the flow is equal to 1,200 meter cube per hour. Okay. Then number 2, select a loading rate, yeah, from a table 15.14. Okay, how to select the loading rate, yeah, in this table? Okay, in this table, very easy, because our interest is only the hydrogen sulfide. Okay, the hydrogen sulfide. So that you straight going to the hydrogen sulfide and you will have to select the surface area. So in this case, the surface, the loading rate. The loading rate is about 90. We choose the value of 90 meter cube per meter squared hour. Okay, so we have to design for biofilter. Yeah, so for hydrogen sulfide, yeah, if biofilter, you have to use any value from 80 to 130. Okay, so if you are to design for other odorous gases, you can choose any value from 20 to 100. Yeah, this is for biofilter. Biofilter means to say that the chemical scrubber. For biotrickling filter, meaning to say that the biological scrubber. I repeat, biofilter meaning to say that the chemical scrubber. Biotrickling filter meaning to say that the biological scrubber. Okay, all right. Next, what do we do next? Select a filter bed depth, yeah, from table 15.14, use 1 meter. Filter bed depth also to be selected from this table. The depth is given as depth of the medium is given, range is from 1 to 1.25. Yeah, select as 1. Then calculate the area needed for the filter bed. So area is equal to gas flow divided by the loading rate. Gas flow calculated earlier, the loading rate from the table, so we get the area. Okay, so check the empty bed resident time. Yeah, and empty bed resident time is equal to volume of the filter divided by the Q. Okay, Empty bed resident time is how do we define? Empty bed resident time is exactly like how we define empty bed contact time. But empty bed contact time, the term are normally used whenever we design for a column filtration. We are designed for water treatment. But empty bed resident time, we use the term is used whenever we design for the gas treatment. So but the concept still the same. If we can define as element term, empty bed resident time, how long that it takes for the gas to pass through the filter media. Same goes to the empty bed contact time. So in this case, empty bed resident time is equal to volume divided by Q. The volume is 13.3 times 1 is the 13.3 is the area times 1 because the depth. So you will get the EBRT. In this case, EBRT is 39.9. So as long as it's bigger than 30 seconds, then it's acceptable. Okay, next, determine if the volume of the biofilter in step 5 is adequate to treat the hydrogen sulfide. Okay, now we have proposed the volume. The volume is 13.3 meter cube. Okay, now since our substance of interest is the hydrogen sulfide, we need to check whether the volume that we have provided for our filters, the volume of the filters that we have provided is sufficient to treat the hydrogen sulfide. So this is the reason why that we need to conduct this calculation. Determine the concentration of hydrogen sulfide using the previous calculation. From example 15.3, the volume of gas occupied by 1 mole at temperature of 20 degrees Celsius is equal to 24.1. We have calculated earlier. Thus, the concentration of hydrogen sulfide is, in this question, you are given that the concentration of hydrogen sulfide in ppm is 40. Okay, so you are going to follow exactly the same step. Use the molecular weight for the hydrogen sulfide. Use the volume of gas occupied at 20 degrees Celsius. You will get the concentration of hydrogen sulfide in gram per meter cube is equal to 0.057. Determine the mass loading rate of sulfur in gram of sulfur dioxide in gram of sulfur per hour. So 1,200 is the flow rate, if I'm not mistaken. Yes, times the concentration of hydrogen sulfide. And these are the atomic weight for the sulfur. These are the molecular weight for the 32 is the atomic weight for the sulfur. 34.08 is the molecular weight for hydrogen sulfide. So in this case, the mass loading is equal to 64.2 gram of sulfur dioxide per hour. Determine the required volume assuming an elimination rate of 65 gram of sulfur per meter cube hour. The elimination rate is given because, as I mentioned just now, sulfur is the compound of interest. We have hydrogen sulfide. So sulfur is the parameters of interest. So you have to refer to the elimination rate of sulfur. Okay. So in this case, the mass divided by the elimination rate, you will get 0.99. So this is the point where you have to check where it will decide whether the volume that we have proposed earlier, the area for the filter bed, the volume for the filter bed that we have proposed earlier is sufficient or not to remove the hydrogen sulfide. So in this case, the volume that required to remove the hydrogen sulfide is about 0.99 meter cube. Because the volume of the bed that we proposed earlier is 13.3 meter cube, is significantly greater than the required volume, which is 0.99. Therefore, the removal of hydrogen sulfide will not be an issue. Okay, because it's greater, greater, significantly greater. Okay, I think that's all. This is the table 15.14 that you are going to refer. Basically, in this table, you need to find the depth of the media, surface loading rate, the type of the biofilter. One second. Just now we use the loading rate. We use loading rate of 90. We have to design the biofilter. Sorry, yeah. I did mention that just now you have to use the loading rate meter cube per meter square hour. Yeah, the loading rate. So the loading rate you are to refer from the surface loading rate. Yeah, meter cube. Volume loading rate. Okay, you have to use the volume loading rate. The volume loading rate in meter cube per meter square hour. In this case, yeah, they use the value of 90. So you can use any value between 100 to 10 to 100. Just now I mentioned that you can refer between this value which is wrong. So in this case, yeah, you have to use the surface volume loading rate, not surface loading rate. Volume, because you are comparing the volume provided. Yeah, so you have to always refer to the volume loading rate. Okay, the rest I think um, the elimination rate. This one is the elimination rate. Elimination rate just now in the question is given as 65 for hydrogen sulfide, but I can see that it doesn't fall within the range. You are given 65 uh, of gram per meter cube hour. So in this case, yeah, you are given for the biofilter 80 to 130 for hydrogen sulfide. For other odorless gas is between 20 to 100. So these are the elimination rate, yeah, for hydrogen sulfide and other odorless gas including ammonia. Yeah. All right. I think that's all. Yeah, these are the molecular weight. Yeah, molecular weight for ammonia. Basically, this one you can calculate from the periodic table. Ammonia, the hydrogen sulfide, yeah? And sulfur dioxide is 64. The hydrogen sulfide just now is 34. Ammonia is 17. Okay, and the last one, this is the point. The point in wastewater treatment plant where it produces the odorless gas. Most of them during the sludge treatment, the major one. All right, so when we employ these types of treatment, if we slash uh, load out facilities, it will there will be high potential for the odorless gas to be produced. Composting facility also very high. Alkaline stabilization, moderate production of the odorless gases. Incineration very low. Slash drying bed from moderate to high. So this is the potential sources and the location for the odorless gas to be produced. Yeah. So I think that's all for today. Do you have any question for this example?
I think
Any
no.
question?
No.
Okay, you check the notes first. In case you have any question, you can send me a personal message.
Okay.
You have to take the final exam as a serious matter because this time around it's a face-to-face final exam. But please don't worry, so definitely we are going to prepare a different uh, orientation, for the closed book exam and open book exam. For open book exam, which is the online exam, normally the question are more on is open-ended, because we would like to avoid the student to copy and to discuss with their friend. But in closed book exam, it's more straightforward question, because you don't have books to refer, you cannot discuss with your friend, and you also have very limited time. So that I will try to prepare a straightforward question, for you to answer, but you also need to work hard. You need to work hard because this is your final semesters, yeah, before you can graduate. Okay, so I wish all of you the best. I'll see all of you on the 16th of July, and please send me personal message if you have any question. Don't forget to submit your project. Okay, so I think that's all for today. Thank you very much everyone for your kind attention, and also please accept my apology if there is anything wrong. Yeah, there is I know lots of interruption during the lecture. Please accept my apology, and I wish all of you the very best of luck. Yeah? Okay. Alright, don't forget to sign in your attendance. So with that, I thank you very much. Everyone have a pleasant evening. Bye.
Thank you, Doctor.
Thank you,
Have a
Doctor.
nice day.
Thank you, Doctor.
Okay, bye.
Bodoh. Bunyi tangan. Hari.